Hello everyone. In this video, we will discuss the concepts of vector calculus. So we all know that vector is a quantity which is having both directions as well as magnitude. So any quantity which is having both magnitude and direction is called as vector. Okay. So like for instance, when you see velocity of an object, force applied to an object, it has both the magnitude as well as direction. Okay, now how do we represent vectors? So, vector, if we define vector in a simple language, we say that it is a directed line segment which is having some initial point and a terminal point. For instance, if I say if I have these 2 points A and B, okay, so we say that AB is a vector. The vector is AB. With when I'm writing it as AB, it means A is the initial point, the point where the vector begins, and B is called the terminal point or end point. And we denote the vector as A, B, initial point and then terminal point. Okay, now how we define the vector in a 3D space, like suppose you have a three-dimensional system, okay, this being your x-axis, y-axis and z-axis, this being the origin. Okay. Now, suppose you have any point here, say P, which is having the coordinates V1, V2, and V3. Okay. Then, the directed line segment, the vector, directed line segment from O to P, we call it as the vector OP. Vector OP. Okay. And its component will be V1, V2, V3. Okay, so the component form of any vector is representing the values of this. Okay, so if we want to write it in a standard form, for that we need to know that it's it's standard that we denote the unit vector along the x-axis as I cap, along y-axis as j cap, and along z-axis as k cap. So the standard form of writing this vector OP, it will be V1 with I, V2 with J, because V1 is the component along x-axis, V2 is the component along y-axis. Similarly, V3 is component along z-axis, so we write V3K. So this is the standard form of writing a vector. And in the component form of the same vector OP, what we will write? We write the same vector but without I, J, and K. So it will be V1, V2, and V3. Okay. Now, if we talk about the magnitude, we write the magnitude. Magnitude is nothing but the length of the vector. Length of the vector, say, let's talk about the same vector OP. It will be square root of sum of squares of each component, like V1 square, V2 square, and V3 square. Okay, so what you learned so far is what is the standard form of a vector from origin, how we can write the component form, and how we can find the magnitude or length of this vector. Okay, now let's see how we can work if we have two different points A and B, and how do we find the vector. So let's say we have point, say, A with the coordinates, say, x1, x2, sorry, let's use x, y, and z, x1, y1, and z1. Okay, let this be another point B with coordinate x2, y2, z2. Then if you want to find the vector AB, it will be, since A is the initial point, and B is the terminal point. We always subtract the component of the terminal point from the component of initial point from the terminal point. So the vector AB in the component form will be x2 minus x1. That will be the component along x-axis. y2 minus y1 and z2 minus z1. Okay, so if we write it in the standard form, we will write it as x2 minus x1. With this, we just have to write I cap, the unit vector in the direction of x-axis. y2 minus y1 times j, and z2 minus z1 times k cap. Okay, now if I ask you, what will be the vector VA? What do you think? What happened in if we are writing vector VA? The same points, but what is happening? You are starting from B and you are reaching to A. Okay, this is your vector VA, correct? In this, it's AB. This black one is AB. This is AB, vector AB. This is vector BA. So what happened? The magnitude or the length is same. Only the change is in the direction. So you can say that BA is same as minus of the vector AB. Okay? Because when you are finding BA, what will happen? Let's see. If you find BA, what you will do? B will become the initial point and A will become the terminal point. So in this case, what you will be doing? You will be finding x1 minus x2, y1 minus y2, and z1 minus z2, correct? Because we always start with the end point, terminal point, okay? So with this, we can say that the magnitude remains same, but only the direction change, okay? So let's see this with the help of example. Suppose you have this example in which you have to find the component form and length of the vector. So sometimes they may ask you find the magnitude of the vector. Okay, so length and magnitude means the same. So how you will begin? In this case, you start with the points. You need vector AB. So this is your initial point and this is terminal point. So write your vector AB. It is always. See, if you write the terms here, what you will have? This is x1, y1, z1, x2, y2, z2. So you subtract minus 2 from 1. So minus 2, minus 1. Let's write it in the component. Anyhow, they are asking for the component form. And plus, it's easier to calculate. Minus 3 minus 2 and 4 minus of minus 3. So when you simplify it, what you will get? Minus minus become plus, so it is minus 3. 3 minus 2, 1. And this become plus 4 plus 3, 7. So this is the component form of your vector. This is the component form. Okay. If they ask you to write the standard form, what you have to do? Just add the I, j and k. 3i, 1j, 7k. Okay. It's same as minus 3i. 1 we usually don't write. J and 7k. Okay. Now comes the magnitude or length of AB. We denote it by magnitude of AB, mod of AB, okay? Which is same as root of, okay, square of components, minus 3 square, 1 square, and 7 square. Adding them, what you get? Root of 9 plus 1 plus 49. So which is root of 59. Clear? Here they are asking you to find the standard unit form and the magnitude of the vector PQ. So magnitude means you have to find the length. Okay. Standard unit form means it should be with I, J and K. Okay. So let's start with the component form because that is always easier. Component form. And in that case, you will always avoid mistake. Okay. Component form of PQ. So P is the initial point, Q is the terminal point. So what you will get? 10 minus of minus 5. 3 minus 4, 3 minus 7. So what you get? 10 plus 5, which is 15, minus 1 and minus 4. Okay, this is the component form, but they ask you the standard form. So write it. Standard form of PQ is 15I minus J minus 4K. Since it's 1J, I write only J. So it's fine. Okay. Then you want the magnitude. Magnitude is nothing but the length. So magnitude of PQ, you can write it as square root of 15 square plus minus 1 square plus minus 4 square. See, it will be easier for you if you take the numbers from the component form to avoid the mistake of sign. Okay? It's always better to use it from the component form because there are high chances that in this case you miss the minus sign. Okay, completing this gives you square root of 225 plus 1 plus 16. Adding it, what you get? 6 plus 6, 12, 4 and 242. This is your magnitude.